In this video, we're going to find the inverse Laplace transform of these three functions. The first one is 3s plus 1 over s squared plus 4. For that, we're going to split this up into two fractions. So here the plus is going to give us 2. 3s and 1 will be the numerators, and then s squared plus 4 will be the denominators. The 3 can come out in front, and that's going to be multiplying that. And then 4 I can just rewrite as 2 squared. Same thing with this one. Now 1 is just 2 over 2, which I can bring this 2 in the denominator. So it'll be 2 over 2 times the quantity s squared plus 2 squared. So now we have to look at the Laplace transform of cosine AT, which is s over s squared plus 8 squared. That's going to be this one, but clearly a has to be 2, and then we have an extra 3 in front. So that's going to be 3 times cosine 2t. So that's the first one. The second one, I'm going to look at Laplace transform of sine AT, which is a over s squared plus a squared. And that's going to be the second one here. Clearly, a has to be 2, but then I have a 1/2 over here. So I can factor out this 1/2 and bring it in front. Because if I just look at the Laplace transform of sine 2t, I get 2 over s squared plus 2 squared, but I need the 1/2, so that's why I multiplied it over here. And so that's just 2 over 2 times s squared plus t squared. So these match exactly. So bringing it all together, the inverse Laplace transform will just be 3 cosine 2t plus sine 2t. The next one will be f of s equals 5 times s to the negative 1 power times e to the negative 3s. For this one, I can rewrite this as 5 over s times e to the negative 3s, which is just 5 times e to the negative 3s over s. So that means this part is of the form e to the negative as over s. And if I find the inverse Laplace transform, that's just u of t minus a, where u of t is the unit step function. But I had 5s to the negative 1 power times e to the negative 3s power. So this 5 will come out in front, and the s will go in the denominator as a positive exponent 1. And so now I could just replace a with 3. So this will be 5 times u of t minus 3. Okay, finally the function we're looking at is 3 over s minus 2 over s squared minus 8 over s minus 6, or 6 minus s. I can pull the 3 out in front as 3 times 1 over s. And then same thing with the 2. You pull that in front, and then I can rewrite the numerator 1. 1 is just 1 factorial, and then 2, the exponent is just 1 plus 1. And the next one I can bring the 8 in front, and then I'm going to pull out a negative. So I'm pulling out a negative, so this will be negative 6 plus s, which is just negative s minus 6. And so these two negatives are going to become positive. So that's where you get 8 times 1 over s minus 6. So we use the inverse Laplace transform of 1 over s to get 1. The inverse Laplace transform of n factorial over s to the n plus 1 is just t to the n. And the inverse Laplace transform of 1 over s minus a is e to the at. So now we just need to take advantage of this. We have 3 over s. That's just going to be 3 times 1 here, which is 3. And then the inverse Laplace transform of 2 over s squared. Well, for this, n is going to be 1. So this will be t to the first power, but we have a 2 here. So this is like 2 times 1 over s squared. So that's why it's going to be 2t. And then the inverse Laplace transform of 8 over 6 minus s. Well, Actually, this one should be s minus 6. This is a typo. That's 8 times e to the 6t, because a here is 6. And so finally we could just bring all of these together, and so that will just be 3 minus 2t plus 8 times e to the 6t, and that is my answer.